find our parameters in some file, we have to click on the configure button to be able to start entering our input parameters. So our configure button will lead us to the new window where we can go and say create new parameter. So it has to follow the order of parameters we created in G+. So first one was wall thickness. Again, SimLab doesn't like some strange characters in its name, like underscore or space. So we'll just call it simply thickness. And then we have to assign distribution. If you remember from Phil's slides, he mentioned quite a few of these distributions, and you can find it on slides from last week lecture. So for the wall thickness, if I remember correctly, it was normal distribution. And which were the values we used on Phil's coursework? What was the mean of wall thickness? Shall we say 20 centimeters or 0.2 meters?
Okay.
Okay. And then standard distribution, let's say 5 centimeters, 0.05. We have to click apply button here and then OK. So this normal distribution with the mean 0.2 and standard deviation of 0.05 is going to be transferred here to the list of input parameters. So click apply, click OK. So thickness has been applied. Second one is conductivity. Normal distribution as well. Let's say 0.8 with standard distribution of 0.2. Apply, OK. Third one, can someone remind me what was the third one?
Lights.
Lights, was it normal distribution? It was?
Yep.
Let's say mean of 12 and 4 of standard deviation.
Temperature.
And the last one is heating temperature. Okay, temperature. Let's say 20 plus minus 2 standard deviation. Is that fine? Or
Yeah.
21. Or
He had the distribution is normal.
yes, sorry. So this one
Sorry, uniform.
was uniform. Okay, so uniform distribution is defined slightly differently. For uniform distribution, we have to define starting point and end point. And in this case, it will be weighting factor of 1, which means that it is equal probability to be each value between start and end. So in this case, let's say from 18 till 23. Is that fine? So left value is 18, right value is 23. Then apply. Okay. Accept factors. So what we have to do now is to define which sampling method we want to use to generate a sample from these 4 input parameters, 3 of them with normal distribution, 4 with the uniform distribution. So which 2 I mentioned are the most suitable one to be used?
The Latin hypercube.
That's the first one,
And the Morris.
And the Morris method. Okay, so shall we start with, in this example to use Latin hypercube, and then if we have time, we'll use the Morris method in the second example. So we'll start with Latin hypercube. By selecting the Latin hypercube, we have to do some more settings related to particular sampling method, which you can do by clicking on the specify switches button. And then it says, first one is a seed. You shouldn't be too much worried about this, but if you want to test different samples with the same size, you would have to change the seed number. So that's like some sort of initial settings for this particular simulation. The important one is number of execution. That defines the size of our sample. So for this particular example, we'll set it up to 20. So just to have 20 simulations to start with something.
So,
when I will try to apply the uniform distribution,
Yeah.
it shows error, weight value error.
Right value has to be 23 and weighting has to be 1.
And weight.
Left, right, it's like corners.
Okay.
Left side,
Right.
right side, and weighting factor is 93.
so in
This
our
one.
in our coursework, if we got up to this stage, we'd put 400.
Yes, yeah, you would put 400 because that's what you've been asked to create a sample size.
No, he's making them up.
So it's 20.
Oh,
The C
12 and 4.
That's because that has been described in coursework. That you've been asked to generate by coursework. Okay. The last thing, now we define the sample size, but we have to now save it to some text file, because SimLab is going to save these settings to text file and sample size generated. So file name has to be written here. So just by defining, I would place it in the same location where our G plus project is, and call it LHS, like Latin Hypercube sampling, and it has to have extension SAM. So and click OK. So you can see these are our configurations for the file. But if I go now and open that file, because it's just a text file, opened in the text editor, there will be nothing there.
Steve, it's 1,
and numbers of like
20.
So here is our sampling file. And you can see it's empty. It is empty. Let me just close a few things here. It is empty because we so far only configured it, but we didn't generate a sample. So by clicking here to generate button, our file will be populated with certain numbers, among which we will have our sample of 20 by 4 options for these 4 parameters. So by clicking on generate button, and go back to the file, you'll see now our LHS file has been populated. So we generated our sample. And what we are interested in is this part of the file. Because this part of the file has 20 lines, and in each line there is value for wall thickness, wall conductivity, lighting heat gains, and heating set point. So this is actually Excel file, the data that you generated in Excel file on the practical session last Monday, but conducted with the SimLab.
But look how many sort of decimal places it's gone up to.
Because it is 32-bit, a lot, let's say a lot. I really don't know. In this case, I think 12 maybe there of them. 3, 6, 10. But see, it is, those 3 are normal distribution, this one with the uniform distribution, and what we have to do now, because now we generated our sample, but we need to run simulations with these values. So we can do it in 2 ways. Doing it by hand, what we did on Monday, going to your file and replacing these in first file, these 4 values at each place where it should be within the file, run the simulation. Or we can use G Plus to help us to execute all 20 simulations in one go. So let me go back quickly to the presentation just to say a few words what we did so far. Yeah, so just to repeat it a few more times, sensitivity, uncertainty analysis, what we actually did, we created these input parameters and assigned some sort of uncertainty, and we are going to evaluate how these each of these of uncertainties in these input parameters affects simulation outputs. And then sensitivity analysis tells us. You can when you speak about sensitivity and uncertainty analysis, you can say you can think about sensitivity analysis as approach from the inputs towards outputs, and uncertainty looking from the opposite direction, from the outputs perspective. So sensitivity is we have in inputs, we have uncertainty in inputs, and we want to evaluate how each input parameter affects
the overall
outputs. Uncertainty tells us we have a bunch of inputs with their own uncertainties, but our outputs is going to be within this certain range of values around certain mean, is that if it is going to be like normal distribution. So what we want to do now is to go back, use this sample of 20 simulations, prepare them to be executed in G+, and then run it through G+. To be able to do that, we need our project we generated here. And it has to be in the same order as parameters used in a sim lab for generating a sample. So first one, thickness, conductivity, lighting intensity, and heating. But because now we generated alternative options somewhere else outside of G+, we are not going to specify these values here. We will use an additional option which G+ provides, which is to look into external file for alternative values, create simulation, run it, collect the data. Then, if you go to the execution tab, you can see option here, job list stored in a certain file. And this file is just CSV file, which we are going now to create to be able to select it here and after that to run all these 20 simulations. So structure of this file follows the structure of our project. So first column is the name of the output folder for that particular set of parameters. Second column is the position of weather file starting from 0. Third column is position of input file starting from 0, because we can select more than one weather file in our parametric project, or more than one input file we can select here and have several inputs as our parameter. And then followed by values for each of these parameters, 1, 2, 3, 4. So in our case, we will take this sample from a text file. So I'll just take these 20 rows, copy them, Ctrl+C, and then paste them in plain Excel file. So by doing this, we generated 20 rows of alternative values for our 4 parameters, but now we just have to add in front of it 3 columns. First one, output folder name, position of the weather file, position of the energy plus file. So I'll just add 3 more columns. Output file name, it is good to have it numbered. So, for example, outputs 01. 01 because there are 20 of them, so it will be easier to sort them after in Excel. Just drag down, got 20. What is the position of weather file? We have one weather file position starts from 0. So what would be the position of that weather file in the list of weather files?
1.
If we are starting from 0.
0.
0. So are you familiar with programming? Any of you?
No.
So do we have a pen here somewhere? Or marker? No, we don't. So these weather file names, if there are multiple of them, they would be put into list. And in the programming, it's opposite of what we got used to. Any list starts from 0. So first item in the list is numbered 0. So that is in convention in the programming. So if we have a one weather file and put it into list of weather files, it will be at the first, it will be only single file in the list, but that position within the list is 0. That is a programming convention, which we followed here. So because we only have a single file, here it will be only 0. We only have a single energy plus file. Again, its position in the list is 0, because it's just single one. So that's from programming. So I'll just copy this 0 to everywhere. And then we have to save this file as a CSV file. So if we save it as Excel file, it won't work, because we need a text file. We need a file which is almost human readable. If we open it in text editor, we would be able to read it. If we open Excel file, XLS file in text editor, we wouldn't be able to read it. So we have to save it with the particular format, which is comma separated value format. So we do that by going to save as, find the location where to save it, and then I'll use the same location where other files are, and say let's call it LHS, and change to comma delimited format, and then save it. It will warn you that you are going to save it with the non-default extension, but that is fine. So if we go to that particular folder and see this file, you will be able to read it. And it is delimited with comma. So name of the output folder, comma 00, parameter 1, value 3, 2, 3, and 4. So now we prepared our file to be able to be read by G+. We have to select it where it is. It's LHS. And then we want to execute simulation. So now there will be 20 simulations, because our sample size is 20, and it will go line by line, assigning parameters from that particular sample 1, 2, 3, 4, and then conducting 20 simulations and aggregate outputs from 20 simulations to the same single output file, which we will need to port back to SimLab in order to conduct sensitivity analysis on these inputs and outputs. It takes a bit of time because my computer is not that fast. Is this clear so far? Is there any question? Okay, that is perfect. And then if you have a look here into output folder, we will get completely new list of output subfolders, which we just named in Excel spreadsheet. So, okay, while it is running, so I'll just say a few words. So what Monte Carlo method is actually what we just did. We took uncertainty in inputs, prepared the n list of inputs which are changed simultaneously, run our energy plus model, which is external to the SimLab, and then we would be able, by loading it back, to conduct uncertainty and sensitivity analysis based on sampling. This is a graphical representation. You will have to do it for your coursework, and this is highly dependent on the type of sampling method you selected for your sampling. For example, this one, if we were selected Morris method, then outputs from the sensitivity analysis would be evaluated by checking a mean and standard deviation. Because we now selected Latin hypercube sampling, the outputs are not going to be evaluated in this way. The outputs will be evaluated by using some coefficients. For example, Pearson coefficient, if you remember, did that on the lecture with Phil. So depending on the type of sampling method, you will have a different graphical representation of the outputs which you will have to analyze for your coursework. And then based on these outputs, you will be able to make some conclusions which parameters are more sensitive, but you won't be able to quantify them in a way. You will be able to rank them. Parameter A is more sensitive than parameter B regarding the particular outputs, but you won't be able to say how much is sensitive, because that's not the purpose of this type of sensitivity analysis.
Wait, hold on.
Sorry?
You said we're not interested in how much it's different, how much it's sensitive by. You said something about how we're not interested in how much different it is.
This sensitivity analysis cannot tell us the proportion among them, how much.
So it can't tell you one parameter is more sensitive than the other.
That is what we will get that answer. Yes, but that is a ranking on sensitivity. Parameter A is more sensitive than parameter.
But it won't tell you how much by.
Yes, we won't be able to say how much by that parameter is more sensitive than other. But the purpose of sensitivity analysis is to give us some sort of ranking and to be able to cut off something. So for example, from this chart, this is the implication on the outputs. So on the horizontal axis, it's a standard deviation on outputs. And on the vertical axis is this is a mean of the outputs, and on the vertical axis is a standard deviation. So how spread outputs are as a function of, in this case, there are five parameters. So what do you think, by looking into these 5 parameters, which are more sensitive, which are less sensitive? So this is the implication or the mean of the outputs, and this is a variation in the outputs, like standard deviation of the outputs. Don't tell me, because you probably can't read what's written here. I also can't read from here, but just location in the chart of more sensitive and less sensitive parameters.
Is it increasing horizontally? Is it increasing from left to right?
Yes.
So
and vertically,
would it
it
be
also increases from bottom to top.
Would it be those top 2 ones on the right?
So those top 2 are more sensitive, yes, than parameters here. So if you conducted sensitivity analysis with such a chart, you would like to pay more attention on preparing and choosing inputs for a couple of those 2 parameters than spend too much time on choosing the correct input on those parameters in the bottom left corner. Or you can completely assign one value and that's it. It wouldn't affect too much variations in the output results. So what we are going to do now is to see first simulation. Did we get some outputs? Hopefully we got something. Yeah, so we got 20 outputs here. So what we have now, we did a sampling, we run some model. So now we have to prepare simulation outputs in a suitable format to be able to be read by SimLab in order to conduct sensitivity and uncertainty analysis. Because we didn't employ any model from built-in models or linked models. So we ran energy plus model, got some results, so we have to format these results and match them to our sample generated by a SimLab in a particular way in order to be seen by SimLab to conduct sensitivity analysis. So to be able to do that, we'll need to create one more text file. And then that particular text file has certain structure. So I'll use file generated by G+, and then very important is to have to rank outputs from one to the last. So because G+ can sometimes place 20 before 17, for example, depending which simulation finishes faster. So we need to sort them, because we have sorted list of our sample, which we want to match outputs against. So first step is to sort them, and then we'll delete everything instead our simulation outputs, which we want to conduct sensitivity analysis on. So first step is to sort them, and then delete everything except our simulation results. So SimLab has certain headings. So those are several lines before the results, which they have to be there in order to be able to conduct sensitivity analysis by using that particular tool. So if I remember correctly, first line is the line which determines how many outputs we want to assess. So in this particular case, we only have one output. If we have 3 of them, that number will be 3. So to be able to prepare that file, I'll just add few empty rows above our outputs. So first line is it's 1, because it is only single. We have only one output. If we